Hello there. I'm Dr. Candace Chambers-Colbeck, and I'm going to introduce you to your lab today. Some of the information for this lab you'll need to get from your lab instructor, so be sure to read information that he or she has either posted for you or emailed to you. By now in your course, you've done some kinematics and some dynamics, both describing motion and describing the causes of motion. Now we're turning our attention to energy. This is really an exciting moment in physics, especially for non-physics majors, because understanding energy is important for all disciplines in science. We're going to look at a simulation of a skater in a skate park. We will collect data on height, or his position in the gravitational field, and his speed. From this information, we can calculate his potential energy and his kinetic energy at any point of his trip. Adding together the potential energy and the kinetic energy at any point in time gives us the skater's total mechanical energy. Are you ready? Let's start. Locate the PhET icon on your iPad and open it. Today, we'll be using Energy Skatepark Basics. You'll want to open the playground. On the right side, you'll see several options of things we can turn off and on. We're going to want the grid and the speed on today. You notice that speed dial doesn't have any units. The units are such that each tick mark represents 1 meter per second. Your instructor is going to tell you what mass to use for your skater. Now we're going to place our 3 data points on here, A, B, and C. So I just drag those 3 data points to the graph, and now I'm placing point A. Your instructor is going to tell you where to put your point A. Now I will place point C. And again, your instructor is going to tell you where to put your point C. So be sure to look at your instructor's additional directions. And finally, I'm going to position point B. So this video is just a demonstration. Your instructor is going to tell you where to put your point B. Now we're going to let our skater go. We'll put him at the top. And let him go. We need to record what the height and speed are at each of these points, A, B, and C. And to do that, we're going to probably want to use the pause button and advance slowly, or use the slow motion and pause. Use some of those features at the bottom to freeze the skater such that you can collect the speed at each of those points. So, how does your total mechanical energy look when comparing points A, B, and C? What were you expecting? Why don't they all match? Mechanical energy is not conserved. Let's go back and look at our PhET simulation.